So, I'm assuming, does the tree of blocks as it's being mined, do you need to have completeness, or can it be sparse?
Oh, it certainly can be sparse.
So essentially not all branches need to be mined, and if some branches are not mined, what's the impact of that?
Nothing. It just means that
what
transaction...
means that higher up. Transactions that are in them?
Well, it just means that if you are using a transaction that's, in some block that by the time you get sparse enough, no one really cares about it, and it gets to, the level of individual miners, well, you might have to go give some miners saying, could you go somehow get this mined? Usually you'd really go use it in a way that, you're still at a level that has a decent amount of mining interest.
Well, and I've had to do that before in practice, with Bitcoin. I've had to send a transaction that got took a week. I sent it to a mining pool and they were able to include it very quickly.
Yeah, and it's not unlike that kind of trade-off.
Well, that means that essentially that gives opportunity for a much more fluid market for fees and for mining power, so you can dial in how much fee you want and how much mining power you want, which means you could have micropayment chains within that. That where you do that trade-off between time to completion and security.
What it gets down to is the usual criticism of Bitcoin for micropayments is, why does the entire world need to know that I bought a coffee? Well, with tree chains, the entire world doesn't. We go pick some security trade-off that's good enough, but it's much better than it would normally be because we're all still working together in this.
So I recently, this morning I had a conversation with Raza from Mycelium Wallet, and they've got an interesting feature built into their local trader set that's a confidence graph. What do you call it? That deals with message propagation. So when I send a transaction to you, usually we'd have, before you'd feel comfortable about it, usually we'd have to wait for a single confirmation at least. And then even then, it would be better if we could wait for more, but a single confirmation is kind of the standard for single person stuff. So what this confidence graph basically does is it tracks the transaction as it goes through the entire global network. And once it has essentially permeated the network, then you can have a pretty high, and it confirms that there's a fee and there are some other things in there, then there's a very high likelihood that even if it's not included in the next block, it will be included in a future block just because it's sitting everywhere waiting to be included in a block. So it seems like with tree chains, this would work even better because, again, it's just the notary system, and once it gets past the mining layer, which is the notary layer basically, it's already in there and it's just waiting to be processed, whether that takes a minute or a day. Am I wrong on this?
Yeah, I think you are.
Okay, please correct me here.
So I think this always comes down to the issue of when is something confirmed. And confirmed is kind of this sort of loose concept.
It's probabilistic, it's not absolute black or white.
And it's even worse than that. If it's never been in a block at all, well, it's not only that it's not black and white, it's not even a shade of gray. We don't even know what color it is per se. We don't.
You don't know when it will be. More. What the probability will be over time.
It could be up to any sort of thing. I mean, I may be a hacker who's hacked in some pool and changed the rules by which they confirm transactions. Maybe I accept the one with a higher fee because I'll make more money that way. That's not against the rules of Bitcoin. It's against what the default client does. But you can certainly argue there's a lot of good reasons to do the opposite and go just take whatever transaction pays whatever fee.
Well, I believe Allegius does quite a few things that are not part of the default client and accept transactions that are not part of in order to increase the diversity of that opportunity.
I mean, I've gone and argued to a lot of miners that they would actually be very smart if they changed their policies to mine the highest fee, precisely because we don't want to get in a situation where we've set a precedent that miners have an obligation to go keep unconfirmed transactions secure, because it's an unconfirmed transaction. You don't even know really if it's been around the network. You don't have any proof about anything about it. I mean, Mycelium, they probably have a bunch of nodes around the world, but how do they really know that their nodes represent the actual Bitcoin network? The reality is they don't. Maybe there's a parallel Bitcoin network. You just don't know this stuff. You don't really know how data gets around.
The only thing you do know is proof of work and increasing difficulty in the blockchain. That's the only guarantee.
An interesting thought experiment would be, well, imagine if there was some way to be sure that after I publish a transaction, it got to everyone reliably. Well, couldn't I just go have a system based on, I can't double spend you because you ran your mycelium radar or something and it got around to the world. Everyone knows it. You don't need mining. If that was secure, you wouldn't need mining. But you need mining because you have no way of knowing whether or not the transaction was actually published.
Well, but again, you're talking about, fringe attack cases, basically. And I think that, again, he made a point of mentioning, Ross made a point of mentioning to me that the graph never gets to 100%. It stays at 99%, and that's where it maxes out.
Well, but this gets back to my comment of how it's not black or white, or even gray. It may be a fringe attack case today, but tomorrow the situation can completely change.
Yeah, a fringe attack case becomes a bot that's doing it 1,000 times a second. We saw that with transaction malleability. It was a fringe attack case for 2 years, and then we had to fix it because it happened to be the main thing that was happening on the network.
Like, I could go spend $1,000 and fire up, 500 Bitcoin nodes on Amazon EC2, and very quickly change the rules that the network in reality follows. And then one of the rules could be that, well, if my Mycelium wallet is connecting to me, I go give them a different mempool than if someone else is connecting to me.
Yeah.
And if I can identify my Mycelium versus other nodes, they'll never know.
And they'll see a lot of nodes it's propagating to, all of which you control.
Or I might just go up to some big mining pool and say, you know what, it'd be in your best interest if you implement replace by fee. And they may choose to go hit the switch on that tomorrow.
So we've had a discussion here where we looked at sidechains and then we looked at some criticisms of sidechains, or perhaps some things that need to be thought about and we need to explore a bit further. So you've presented tree chains to us. Now I'm saying hash includes criticisms.h. I'm going to throw in any criticisms that you think you've heard or other people have discussed. Assume that I just voiced all the criticisms that you've seen in your discussions. Can you say, what are those? How do you address them? What are the weak points that people have concerns about? Give you an opportunity to talk about some of those now.
In tree chains?
In tree chains. Yes. In tree chains, yeah.
Well,
then we'll get Austin and Adam back, and then they can actually provide those criticisms post facto.
I think the big catch is that using tree chains efficiently is certainly hard. It requires a lot of, if not clever cryptography, at least in the same way as Bitcoin, it was quite clever about how it structures its data. You need to go have these proofs. You need to be able to go and show someone else that something was published in some chain. And that's significantly more complex logic than Bitcoin, which is really dead simple in terms of how the crypto works. On the other hand, I also got to point out that sidechains has all those issues too. And as they're solved on sidechains, those solutions apply equally well to tree chains. I mean, a way to go think about moving value from one node in this tree to one block in this tree to another is, that's a sidechain. And I've proven that money was taken out of that block and now should be resurrected here. All the same techniques actually apply. So I'm kind of excited to see all the stuff they're going to come up with clever crypto. But I think the underlying layer shouldn't be merge mining. It should be something like tree chains.
So you can implement many of the same goals using many of the same primitives, but in a way that doesn't require merge mining.
Absolutely. I'll bet you 90% of the work in implementing tree chains is going to be the 90% of the work in implementing side chains. It's a 10% base layer that's actually my criticism. That's all. And
so what requires a hard fork here? Both things require a hard fork, right?
No.
Neither things require a hard fork?
Yeah, neither.
So how does that work? How do you implement something like tree chains or side chains without doing a hard fork, without changing the core protocol in Bitcoin?
So now a hard fork, to be clear, is a protocol change to Bitcoin, a change in the way the rules of Bitcoin work, as opposed to a soft fork, which is
a non-backwards compatible change, not just a change, but a change that requires all clients from that point on to follow the new rules, because the old rules cannot see the new rules.
I see. So everyone must change in the event of a hard fork, versus in a soft fork where they do not necessarily have to change. It's backwards compatible.
To be clear, so what a soft fork does is it tightens the rules. After the soft fork, blocks to the old to the nodes running the old rules appear to be valid. In a hard fork, we make changes where the new blocks following the new rules appear to be invalid. But the thing is that...
So let's give a specific example. Multisig and pay-to-script hash addresses. Any old client seeing a pay-to-script hash address...
Which is...
what is
which is pay-to-script hash is the multisig addresses that start with a 3. Mm-hmm. Before November of 2013, an old client that saw a 3 address on the network would say, what the hell is this? And drop it. It would be considered invalid. So that's a hard fork, because when you introduce that...
No.
That wasn't a hard fork?
No, that was a soft fork.
That was a soft fork?
Yes.
But it changed, it created things. Okay, great. So let's explain that.
Okay.
Rewind back to Steve.
So P2SH is a good example of a soft fork where it's called pay-to-script hash. We go take a script, which is the rules required to go spend a Bitcoin.
And the best example of that is multisig.
Exactly. And we take that and we hash it and turn it into a little number. And then we go say, can you go provide me a script that hashes to that hash? If you can, and you can also meet the rules of the script, you can go spend the money.
So a 3 address.
Escrow. Yes,
it can be used for escrow.
So with multisig,
yeah.
It is escrow. It is escrow that is controlled by more than one key.
Yes.
So it's a 3 address. That 3 address doesn't represent a wallet. It represents a script, and that script has rules for escrow, multisig escrow in it. And if you can provide the script that has the multisig rules in it and the signatures that validate that script, then you can spend what's in a 3 address.
Okay.
Best explanation I've heard yet. Yeah. Okay.
So here's the crazy hack that made it a soft fork. It's that we added a new rule to the Bitcoin protocol that said if you saw a script that consisted of nothing more than hash that data and then check if that hash was equal to an existing hash, we'll perform that as it always would, but then we'll also go and take the data and then run it as though it were a script.
Right, and that was a really nasty kludgy hack.
I don't know what any of this means. So
yeah.
Can we...
So what does that mean in the...
All right, so you have a node, and I go give you a script that says, well, these coins can be spent if I provide you with a piece of data that when hashed happens to go match an existing hash.
Mm-hmm. The 3 address.
Yeah. Your old node looks at that, runs a little bit conscious. Oh, yeah, that's fine. I don't know, why did you include all that other stuff there? But that's okay by the protocol, so you just ignore it and you're good to go. We upgrade that and we say, well, if you see that in that little very specific form, we'll add a new rule where then you go take that data, treat it as though it was another script, and then go validate it according to the Bitcoin script rules. Now, you, the old node that sees new transactions by this, you just ignore them.
Right.
They're valid from your point of view.
But the new nodes open it up and say, oh, this particular script is a multisig. It requires escrow. Now I need to count 2 out of 3 signatures to validate this.
Yeah.
The old node isn't seeing the multisig, isn't seeing the escrow, isn't seeing the 2 out of 3. It just sees a valid address and says, okay, whatever that is, I'll just take it.
So it seems like this is analogous to like what Mastercoin or Counterparty do, basically, where where you've got this you can send any sort of Mastercoins to a Satoshi client. The Satoshi client can't see them, but the address still controls them at the point that you move from that to the
And the key difference with Mastercoin is because it's client-side validation. You don't need a soft fork. You don't need miners to do anything.
Well, this is layering of protocols, and this is separation of concerns. So in a distributed system, this is very much equivalent to a TCP client forwarding things to port 80, and it doesn't know what those things are. But if you have a web client, it can take those port 80 things and say, hang on, let me open this up. Oh, this is a web request. Now we're going to send web pages instead. And the TCP client doesn't need to know any of that detail. It can just forward things to port 80, not knowing what's inside them. In the case of Mastercoin, the Exodus address is the equivalent of port 80. And the underlying Bitcoin client forwards them along without understanding what's inside, but the more sophisticated Mastercoin that's running a layer above can unlock that and do additional things with it.
Now I understand the Exodus address a little bit better, too.
It's your port 80. It's the HTTP address.
And going back to tree chains and side chains, well, how do you go soft fork tree chains or side chains to add them? Well, you simply go add new rules. You go say if you have a transaction that's a special format that to old nodes looks like just meaningless data, well...
Meaningless but valid data.
Meaningless but valid data. And by valid, all we mean is that the data was encoded in the standard push data to the stack format. Well, now the new nodes go say, okay, well, let's go, that's a sidechains proof. Let's go apply this proof. Let's go figure out whether it's valid. In the case of tree chains, you do this implementation even easier. It's actually just merge mining. Mm-hmm. It's merge mining where the rules follow a particular pattern so that the whole system can go work in this multi-level deep thing. But for the old Bitcoin nodes, seeing only the first top blockchain, all they ever see is, I guess it's a block and it had 2 more hashes in it. And maybe if money needs to be moved from the lower parts of the tree up, you use the sidechains protocols.
I think this goes well to prove the underlying theme of the last several years and of many of the conferences I'm going to. This is not a damn currency.
Yeah.
This is not about coins. Yeah. You are missing the point. Yeah. These little discussions really show how far we've come from, even from the title of the Satoshi paper, a distributed digital cash system, and it's absolutely no longer about cash. And it's so much more than that, both in terms of the applications, but even in terms of the complexity of the implementation. And the amount of innovation that's happening here has nothing to do with coins anymore.
And, I like to go make the analogy of the telephone network versus the internet. Mm-hmm. I think something like sidechains is not unlike the way, how do we add features to the telephone network? We went up to the telephone carriers and said, look, could we do this? Could we do this? And the same way you're going up to the miners saying, could you merge mine my coin? Could you merge mine this coin? Whereas tree chains is more like the internet, where we have this really, really, really low-level protocol, IP. And if all you want to do is just be an internet router and move IP packets around, that's great. Go for it. The fact that there's a whole bunch of other stuff built on top of that, you don't need to know about. You don't need to care. And if I want to go and experiment, I can. And it works just as well as your experiments. It works just as well as your production-ready token transfer system or your Bitcoin system. Who knows what you're doing? But it all works because the underlying system works.
And that it's important to realize that if you do the protocol layering well, you get 2 very, very important side effects. The first one is that you can preserve the neutrality aspects of the core protocol, which means that as long as it's from A to B and some content, you don't need to understand what that content is. You simply deliver it, and that allows the innovation to flourish within that system. And the second one is that if you structure it correctly, the layers above do not affect what happens in the layers below. And that way you have separation, you have modularity, you don't have weird side effects happening. And that's critically important because then the innovation can go completely at the edges and you can have all of these applications flourish.
I mean, hey, I go work for Mastercoin, Counterparty, and some other ones. The fact of the matter is I don't actually care that much whether or not Mastercoin survives or Counterparty survives. What I care about is they were given a chance to test their protocol, see if they could make it work, and they had the security so that they weren't going to be killed off by a small group of people who might decide this is a bad thing. And I want, the space to experiment. And I think people should have that shot at trying.
No more monopolies.
Yes.
Yes, because even if we get Counterpoint or Mastercoin or any of these other things wrong, once you open the door for things to be built on top, someone else will build it right. And there'll be a marketplace for people to try all variations and decide what is right for them without having to ask the permission of the underlying layer. That's the really important argument that's been going on in the Bitcoin space for a while now. That's why the ideas of spam and dust and bloat of the blockchain can be seen from 2 different perspectives. One, it's bloat, but on the other side, it's an opportunity to open up all kinds of applications without having to stress the core development team or to request protocol changes in the core layer.
So what's next for tree chains? It kind of sounds like this is at the ideation level, and you've thought about it. It sounds like it's an interesting solution to a similar type of problem that that side chains are trying to solve. So, how's it going?
It's a matter of sitting down with a pad of paper and working out the details. I think an exciting possibility is, for instance, Ethereum. You could actually go ship Ethereum as a tree chains thing with no scripting at all. Crazy enough. And add scripting in later as soft forks. So if you did want the miner validation on top of this idea, all right, fine. Add it piece by piece. If you didn't, that's okay too. Equally, you can take the same idea and apply to Bitcoin. I'm not quite sure yet in what form the first pieces of code will be written, but I expect that to be fleshed out much more in the coming months. And simultaneously, whatever the sidechains guys do, their experimentation will feed into the crypto that's in the understanding that's going to make tree chains work. In the same way that Mastercoin and Counterparty, their experimentation with the concept of client-side validation will feed into making tree chains actually work, from a pragmatic point of view. So,
and you could implement this, not only use this to implement Ethereum on top of Bitcoin, you could also implement tree chains within Ethereum, for example, as its own mining approach, or any of the alt chains.
Well, this has been a pretty mind-expanding... Ow.
Does your mind hurt when it expands?
A little bit. Lots of brow furrowing this one, but...
this was cool. Thanks for explaining a little more detail for those of us who don't have the technical background. I hope the listeners will be able to keep up, and I think they will be.
I think that, as we learn along, so hopefully they. And so Peter, you do lots of projects. If somebody wants to get in touch with you, what's the way to do that? If somebody wants to support your work, is there any way to do that?
Email me.
Email you. Okay.
Simple as that.
Okay, you want to give that?
Yeah. Pete at petertodd.org.
Pete at petertodd.org. Okay, well, I think that wraps us. I think that wraps it up for us this time.
We're done.
Guys.
No more conference.
Yeah, no more conference. All right, guys. This closes out our recordings at the Toronto conference. Thank you all very much for being here. Andreas.
Thank you.
Stephanie. Peter. Thank you very much. This has been good.
Welcome.
I really I'm going to be paying attention to this and trying to continue to keep up with you. Keep the good work.
Yeah, thank you.
I think the feedback we've received, at least the feedback I've received, is that when we do more technical, more in-depth episodes, like the one I did the first one I did in Vegas with Adam, I think that was probably the most in-depth one we've done up to that point. People go back and listen to it again and again and again and try to decompress all of the ideas. And I've had so many people come to me and say, that was just amazing. Not only did I learn a lot of new things, but in trying to learn those new things, I learned a lot more about Bitcoin than I ever thought. I think we can challenge the audience, and the audience absolutely loves it.
They're going to be challenged.
But they like that. It's not like we don't need to patronize our audience. No, we have episodes that are great for beginners, and we need to give them the real meat and episodes that are great for people to expand their understanding.
That's what we do, is we try to, it's just, it's a learning process. We're learning along with it. I think it's always good to have, the three of us here, because we represent a range of experiences and contexts.
A good dynamic.
Yeah.
You can also do themed ones as well, like some more techie, some more social kind of stuff.
Yeah.
Side chains of Let's Talk Bitcoin.
Yeah, side chains of Let's Talk Bitcoin.
Whenever you say you're going to make different podcast feeds, I say there's going to be a hard fork. Bitcoin podcast.
I like it. All right. Well, I think that wraps it up for this time, guys. Thanks, everybody.
You're welcome.
Hey folks, Adam B. Levine here with an experimental sponsor today, a hiring one. David Johnston said it best, anything that can be decentralized will be decentralized. Reverse Dealer is that idea applied to buying and selling of cars. At Reverse Dealer, the people are the dealership and the whole point is to save everybody money. The founder writes, quote, "We are the exact opposite of a traditional dealer. We are the change we want to see in the world and we are currently hiring. They're looking for one skilled developer, a social marketing expert, and they're interested in speaking with additional investors as well. Interested? Send an email to reversedealer@gmail.com.